Hi, hello everyone. Welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for class 11 CBSE Applied Mathematics. Yes, we have already seen our first chapter of time and work. There we happen to see two main important concepts about how to compare manpower and time, and how to compare or get a relation between manpower, work and time. Everything we saw in our previous session, in the chapter 1 part, and there also we saw few problems. I think we worked out some 3 questions based on those concepts, and if you have missed that video, kindly see that video. This video is actually the continuation of the previous video. You can see that video. It is going to be just before that video in the same playlist. Yes, and here this is chapter 2 of time and work. Here again we are going to see another more important concept of time and work. Okay, yes. So if you see here, we are going to solve this time and work very typical questions using two important methods. Those two things are what? Those two important methods are what we are going to see here in this session. Okay. So the two methods are actually fraction method and unitary method. And if you just see, so this one is actually going to be a very strong base for your quantitative aptitude. Maybe in future, if you happen to prepare for any important competitive exams, maybe any competitive exams like state level or national level, you happen to prepare for bank exams, or you may attempt some railway exams, you may prepare for management exams like CAT, MAT, ZAT, many exams are there, right? So in all those exams, you will definitely find questions based on this time and work, and the concept that you are going to see here in this session is really going to be very helpful for you to understand or get a help, go through very easily when you prepare for those exams in your future. That's what I would like to insist here itself. So how come if a problem from time and work is given to you, how can you solve those problems? How can you solve the problem using these methods? So what I'm going to do here is I'm going to take a typical time and work problem and individuality. Two individuals I'm going to take. They are going to finish the work in these many days. Like that, I'm going to take a question and I'm going to show you how to work that problem in both these methods. Let us see them one by one. Yes, here we go. First of all, let us see what problem is given to us and try to understand it. Our question here is A and B are two individuals, and A can complete a given work in 15 days, and also B can complete the same work in 10 days. So in the first part of this question, we have got two informations, that is, we have two people A and B, and also it is given that out of them, this A can complete a given work in 15 days. This is given. And the other person B can complete the same work in 10 days. So these two pieces of information are given to us. Let's continue. If they both work together, so now what happens is they are going to work together, and these informations are when they work individually. When they work alone. If A alone works, A can complete the work in 15 days. Similarly, if B alone works, B can complete the work in 10 days. Now the question is, if they both work together, that is, if they are going to work combined, if they are going to work together, how long will it take for them to complete the same work? So very simple question, very basic question for us to understand. So if they are going to work together, A and B, they are going to work together. Now in this case, how long will it take for them to complete the work? This is going to be the question. And as I told, we are going to try this question in two methods. So the first one among them is fraction method. Now using fraction method, we are going to solve this question and get the answer. Shall we start? Yes. I've just prepared the data. What are all the steps which are needed on the way? I've just prepared everything. Now all we need to do is we are going to fill them one by one so that easily we can get the answer. Let me explain all these steps when we go through, okay, one by one. Yeah, as I told, let's begin solving this problem using fraction method. Fine? Okay. So starting with, What is the 1 day's work of A? See, A can complete that full work, whatever work is given to them. A can fill or complete that entire work in 15 days. This is what we are given in the question. And here what we need is, we'll try to calculate what part of the work or how much portion of the work can A do in 1 day. That's what I've written here as 1 day's work of A is how much. Can you think of what is 1 day's work of A? Just imagine, let's take a very simple example. If I give you a work and you are taking 2 days to complete the work, then what does it mean? If you are doing that work uniformly, then what does it mean? It means for every 1 day you are completing half of the work. I mean, the first day you take the first half of the work, you complete it, and second day you complete the second half of the work. And so hence what happens? You will complete that entire work. I mean, the complete work you will take 2 days to finish. That's it. What if you take 3 days to complete the work? Say I'm assigning you a work, you are taking 3 full days to complete the work. What does it mean? It means every 1 day you are completing 1/3 portion of the work. That's the meaning, right? Same way, here A is taking 15 days, in the sense every day, I mean each day, how much portion of the work is completed by A? Very simple. Just take the reciprocal of that. Like 2 days we took 1/2, which means 1/2. 3 days we took 1/3, 1/3. Same way, A is taking 15 days, so that means in 1 day A will be able to do 1/15 of the work. Okay, so let me put 1/15 of the work. I'm writing it. So what is the meaning of 1/15? What's the meaning of this 1/15? 1/15th. It means 1/15th of the portion of the work is completed by A in 1 day. That's what I've written here. Yes, let's have it as it is. Continue. Same way, 1 day's work of B. So if B is capable of completing the work in 10 days, then in 1 day how much work B would have completed? Again the same thing, we have to take the reciprocal. I mean, B would have completed 1/10 of the work in every 1 day. I mean, in 1 day B is capable of completing 1/10 of the work. That's it. Okay, we'll continue now. What's the third thing we have here? 1 day's work of A and B working together. That is, now A and B, both of them are going to work together. That's what is asked in the question, right? So in that case, in 1 day, if A and B both are working both together, totally how much of the work they will be completing? This is what we have as the third step, for which what we have to do. See here, if you can complete this much piece of work, your friend can complete this much piece of work, each in 1 day, 1 day. Then if I ask you what's the total work completed by both of you in that day, what do you do? You have to just add it. That's it, right? Very simple. Same thing is what here also we are going to do. So A and B together can complete how much of the work in 1 day? The same. Here also the 1 day's total work is what we are calculating, for which what we have to do? We can just add up these two values. We can do that, right? So 1/15 plus 1/10. We'll just add them up. Okay, fine. So to add this, we have to take LCM because we are adding two fractions here. So we see the denominator numbers here. So I've got 15 here, 10 here. So we have to go for the LCM of 15 and 10. That's what we usually do, right? So what is the LCM of 15 and 10? It's simple for us to get it, right? Because out of them, the bigger number is 15. So go think of 15 tables. That will easily give you the answer. 15 ones are 15. No. 15 twos are is 30. Yes. 30 is divisible by both 15 as well as 10. That means we'll just stop with 30. That means the 30 is the LCM of 15 and 10. Okay, done. Okay. Now this 15 in 30, it is how many times? It is actually 2 times. Is it or not? So the same thing is what we are supposed to do in the numerator also. I mean, here we did 15 twos are 30. Same doing here. 1 twos are, it will be 2 plus here 10 I have. So 10 in 30 we have 3 times. So 10 threes are is 30. Doing the same here in the numerator also. 1 threes are, it is going to be 3. So 2 plus 3 by 30. So that will give us 5 by 30. Is it or not? So let me write it here. 5 by 30. I think we can even simplify this. 5 by 30. So 5 by 30 both are divisible by 5 tables. So it will give you 1 by 6. Is it or not? Because 5 ones are 5 and 5 6 are 30. So it gives you 1 by 6. So this means A and B together can complete 1/6 of the work in one day. This is what we arrived. Yes, fine. That we have noted here. So they both can complete 1/6 of the work. Now final step. Here is where we have the answer. We are going to get the answer. So final, what's the thing? Number of days taken by A and B together to complete the whole work. Actually, that is what is asked in the question. Say here. Just see here. If they both work together, how long it takes for them to complete the work? That's what is asked here, right? So now we are going to get the answer. It's very simple for us to get the answer. See the previous step. If in one day A and B both together can complete 1/6 of the work. Understand it very properly, very carefully. In one day they can complete 1/6 of the work. Then in how many days they will complete the entire work? I mean the full work. How many days it will take? It is exact this reverse of what we are doing in what we did in the first step. I think you are able to understand it. Try to match it with this. See here, in 15 days A can complete the entire work. Then in one day A can complete 1/15 of the work. Now the same thing. If in one day A and B can complete 1/6 of the work, then in how many days they can complete the full work? Just we have to again get the reciprocal of this 1/6. So what is the reciprocal of 1/6? 1/1/6. That's nothing but 6. So that means in 6 days they would be able to complete the entire work. Okay. So all we need to understand here is 15 days. If some person is going to take some X number of days, then in one day the same person can complete 1/X portion of the work. And if in one day, if some 1/X portion of the work is done, then in X days the entire work is done. Vice versa. Okay, we have to understand this. We have to clearly understand this relation. So this way of solving the problem using fractions is what we call it as this fraction method. I hope this method is clear to you. So we read the question, we take whoever is completing in what many number of days, or sometimes you may even get your questions in terms of hours also. A can complete a work in 10 hours, B can complete in 20 hours, whatever. Okay, so that units is that doesn't matter, whatever it is, days, in the sense we have to take days here. Hours, we have to take hours here. That's the only thing. Okay, so we have to take it and we have to find the 1 day's work or 1 hour's work, whatever, according to the question, how we get it. So we take it, we arrive with the fractions, we take the fractions, we add them up, and finally again to find the number of days when they work together or whatever, we have to do what? We have to again take the reciprocal of what we are finally getting. That's what. Okay, so this way of solving is what we call it as fraction method. Why it is called the fraction method? Because all the way we are using fractions to solve this problem. That's the reason we are naming this to be a fraction method. I hope this method is clear to you. And now next we'll try to solve the same problem using the second method, which is unitary method. Yes, the same question now by unitary method we are going to solve. So let me not start reading the question from the beginning. We are clear with what is asked in the question. So I'll tell about this unitary method. Like in fraction method, we used all fractions in order to solve it. Here, without fractions, we are going to use units to solve this problem, and that's the reason this is named as unitary method. And as a first step, in the first step itself, what we are going to do is, we are going to assume this total work. This total work is equal to some units. In that way, we are going to assume, and we start there. From there, and everything will come in the steps. They will be coming in the following steps. And this pattern is what we are going to follow here in this unitary method. Let's see how it is going to work here now. Fine. So the same question, A can complete a given work in 15 days, B can complete the same work in 10 days, and A and B totally how many days if they work together. So the first step itself, I am going to assume what work they are going to do. They are going to work on some assignment, right? They are going to work. So what work, how much work they are going to work? That work I am going to assume as some number of units. That's what I am going to do. And that too, in what way I will assume that number is, I will see a very comfortable number, a very easy number with which I can do my calculations very easily. In such a way I am going to assume the numbers, for which what I have to look for is, I have to look at this number of days first. So A can complete a work in 15 days and B can complete the same work in 10 days. This is what is given, right? So I can see the numbers 15 and 10. Now think of this 15 and 10. Think of the LCM of 15 and 10. Just before, when we try to calculate using fractions, there we happen to take LCM, right? So the same LCM we are going to do now itself, in the very first step itself. So what is the LCM of 15 and 10? It is going to be 30 actually, right? So 15 twos are 30. So 30 is divisible by both these numbers. So very well, I can take 30. So what I am going to do now is, I am going to take the total work to be 30 units. This is where I start. Yes, done. So whatever work that A and B they are performing, they are going to work, right? That work is 30 units. We will have it as a number so that it will be very easy for our understanding. Yes. Now let's continue with, as usual, the other remaining steps. Yes, ready? Yeah, fine. Now A's 1 day work, 1 day's work of A is equal to how much? That we have to calculate. See, I know the total work is 30 units. Just now we assumed. The total work is 30 units. And see here, this 30 units is what A is completing in how many days? 15 days. In that case, you think and tell me, in one day, how much units of work A would have completed? That way we have to think. 30 units completed by A in 15 days. Then that means in one day, A's 1 day work, it will be how much? Simple, right? I can divide this 30 by 15. So A can do 2 units in 1 day. That's the point, right? You can even think like this. So I can write 30 pages of assignment in 15 days. So that means what I am doing? I am writing 2 pages each day, every day. So that I can complete 2 15s are 30. All the 30 pages I will complete in 15 days. The same calculation. 30 units in 15 days. So in every 1 day, A can complete 2 units. That's a 30 by 15 I am dividing. I am putting 2 units every day. Okay. Now 1 day's work of B. So again, the same work 30 units is done by now B in 10 days. So B can do how much units of work in 1 day? Same way we have to divide. So 30 in 10 days. So that means B is capable of finishing 3 units in every 1 day. So now we are ready with A's 1 day work 2 units, B's 1 day work 3 units. Fine. Now go work the third step. 1 day's work of A and B together. If the A and B they both work together, in 1 day how many units they would have completed? Very simple. A alone can complete 2 units plus B alone can do 3 units. So if they combine and work, if they work together, they can complete 5 units in 1 day, right? Yeah, okay, fine. Now the last step where the answer is number of days taken by A and B together. The total number of days they take in order to complete the entire work. What is the entire work? The 30 units. See, the total work is 30 units, and each day, for every 1 day, they are working 5 units. So in that case, totally how many days will they take to complete the full work? If I want to find that, what I should do? I should take this 30, I should divide it by 5. Why I am dividing? It's simple for us to understand. 1 day I can do 5 units. 1 day here in this case, A and B together can do 5 units. Then in order to complete this 30 units, how many days will they take? I have to divide it. 30 by 5 I am dividing, and my answer will be 6 days. So I hope you will be able to match with the previous scenario. There we worked out in fraction method. There also we happen to get the same 6 days to be our answer. Here we are working out with unitary method, and here again we are getting the same answer. Yes, okay, fine. Yes, being mathematics, in whatever method we work, our methods may vary, but our final answer will be always unique. It will be a correct answer. Yes, fine. And yes, now you can just compare both these methods. Actually, we tried fraction method and also we tried this unitary method. You can compare both these methods and now you can see which one is better. It is up to you. And actually, to my preference, I will take this unitary method to be more comfortable. Why means? There's only one extra step here. Of course, when you compare to fraction method, there's one extra step here, and that extra step is what is you assume this total work. The very first step is what is that one extra step. Though you have this one extra step here, everything, all the other remaining steps are very much convenient for you. It looks very comfortable for you. instead of seeing anything in terms of fraction, if you look at them as mere numbers, it would be very much comfortable for you. It would be very easy for you to visualize. Like for a very simple example, if I tell you there are 12 chocolates, there are 12 chocolates before us. If they are spread like there are 12 chocolates, and if I simply tell you like I take 1/3 of them and I give you half of them. So what does it mean? It means I take 1/3 of them means I take 4 of them and you take half of them. That means 6 of them you take. So seeing half or 1/3 will be bit. It would be bit harder for us to make ourselves feeling comfortable with seeing them as mere numbers. I take 4, you take 6. This looks very simple, right? Very cool also. So that's the reason this unitary method, if you take, it is going to be very much comfortable. Since you don't play with any fractions, you don't have big risks in your calculation, you can see everything as mere numbers. It would be very easy for you to proceed your calculation, and the way of getting the answer will also be easy. That's the reason this unitary method is little comfortable than compared to this fraction method, the previous method. And however, I hope that you are able to understand both these methods of solving. I think you are very much clear with both the methods, and if you still find doubts, you can just rewind this video and play them until you understand. And even if you feel that you have any toughness in understanding, please kindly comment it in the comment box, whatever doubts you get, and if I see them, I will help you verifying the doubts. Okay, yes, fine. Again, in the next session, in chapter 3, we'll try to come out with other different concept of this time and work. See you soon there. Thank you so much.